theta. Okay. Let's look at the graph of that. Two cosine 4 theta. Two cosine 4 theta. It's got 8 leaves. It's one of the 8 leaf ones. I want to know the area of one of those loops. And basically, the first loop does that. And then the rest of them go from there. Yeah, there's 8. And actually it starts here and then it goes around and finishes up right there. Okay. Question is, how are we going to get, because it's not maybe as easy as you think, because really, yeah, if it was cosine theta, you know, that's no problem, but it's cosine 4 theta. That's what complicates it up a bit. It's not 0 to just 0 to pi or 0 to pi over 2, something like that. So the trick is to figure out how can I sweep out that area right there. Well, let's take a look at this in Cartesian mode. Function mode. Just regular function mode. So let's change my mode. Back to function. And then all I'm going to do is I'm going to put in y equals 2 cosine 4x. And if you know how to graph that by hand, then by all means do that. But that calculator can help you out. All right, so here's what it looks like. All right. Here's what you need to realize. One loop of this, what is happening is I've gone here, I'm right at the origin, if you will, which is, what's the radius? 0, radius 0, and then I've gone around, come around, the radius is changing, and I'm back to the radius of 0. So I've gone from one radius of 0 to another radius of 0. Okay? Now on this graph, so it's basically that's what I need to do. I need to go from one radius 0 to another radius. What's the radius when I change it over here? The radius is y. So I'm going from one y equals 0 to another y equals 0. Where is y equals 0 on this graph? Isn't that y-intercept, x-intercepts? Y equals 0. So I'm going from an x-intercept here to another x-intercept here. That's one loop. One loop is between x-intercepts. I just have to figure out what my x-intercepts here are. Okay. What are the x values? Well, we know best way to figure that out. What is this to this? Well, you remember the periods. What's the period of this thing? Isn't it 2 pi divided by whatever that number is? Remember that? Period's pi over 2. And the way I used that when I was graphing these is I used that to divide that up at least into, so one period is pi over 2, so one period is one cycle. So if I go from this all the way to there, that's one cycle. So that's pi over 2 right there. You with me? All right, so pi over 4 would be there. What's that? Pi over 8, isn't it? Because they're dividing up basically into quarters. That's how I look at that and figure that out. That's pi over 8. So what is that? It's minus pi over 8. So if this is represented here by this picture here, this part of the graph here. So that's from minus pi over 8 to pi over 8. So this area, to sweep out that area, I need to go from minus pi over 8 to positive pi over 8. That's how I figured that out. Okay. Now, I need to do my 1/2 r squared theta to finish this, r squared d theta, to finish this off. So what would that, what is that going to be? It's going to be integral 1/2. The r is cosine, 2 cosine 4 theta squared d theta from negative pi over 8 to positive pi over 8. That's the area of one loop. And we'll do another one to see if we can get the hang of it here. All right. So that would be 1/2. I'm going to leave the parameters off here. What would it be? 4 cosine squared 4 theta. I want to square that out. Well, the 1/2 times the 4, that'll cancel to be 2, won't it? 2 cosine squared 4 theta. D theta. How am I going to do that little integral? It's another double angle, right? Cosine squared theta equals 1/2 plus 1/2 cosine 2 theta. Well, I don't have cosine squared, I've got cosine squared 4 theta. Well, that just means do 4 theta instead of theta, so that's 4 theta there. So it's 1/2 plus 1/2, 8 theta? See that? Cosine squared is 1/2 plus 1/2 cosine 2 theta. So cosine squared 4 theta would be 1/2 plus 1/2 cosine 8 theta. Right? Believe that? Okay? D theta. Multiply the 2 in there. That'll be nice. That'll just be 1 plus 1 cosine 8 theta. So that's not too terribly difficult of the antiderivative. The antiderivative of that will just be theta, won't it? And then this will just be a little u substitution. U equals 8 theta, du equals 8 d theta. So du over 8 is, so this will be the integral of cosine of u times du over 8. So it's going to be theta plus 1/8. Antiderivative of cosine is sine of u, but u is 8 theta, so I'm going to put that in there. 1/8 sine 8 theta. And that is from negative pi over 8 to pi over 8. That's going to work out nicely. Plug in the pi over 8. So we have pi over 8. That'll be 1/8 sine of 8 times pi over 8. But that's just going to be sine of pi, isn't it? minus, plug in the minus pi over 8, so that'll be minus pi over 8, plus 1/8 times sine of 8 times negative pi over 8. Well, that'll just be negative pi. So pi over 8 plus 1/8 sine of pi. Actually, that's 0, isn't it? Don't need that term. Minus minus pi over 8 is plus pi over 8. What's the sine of minus pi? And that's 0. So it's pi over 8 plus pi over 8. 2 pi over 8. Just pi over 4. So one loop is pi over 4. You hang with me one more example, just to get through these leaf ones. If you need to go, that's fine too. All right. Find the area enclosed by R equals, all right, so yeah, this one's, I'm just going to do the whole area enclosed by, not just one loop, but the whole thing. But, let's look at that one. 2 sine 3 theta. Oh, need to go back to, change my mode here. Need to go back to polar first. Let's look at what the graph looks like. 2 sine 3 theta. How many leaves that one got? This one's got 3. It's got 3 leaves. Okay? So I want to find the whole area swept out there. Good news, though, is the total area is just 3 times one of the loops, because all these loops are symmetrical. Okay? So to find the total area, let's just find the area of one loop and multiply it by 3. That'll be a whole lot easier, don't you think? Instead of having to do all 3 loops. Okay. All right. So let's try that out. Okay, so I'm going to find the area, say, of this one loop right here. How would I find the area of that one loop? Call it loop 1. Well, like we said, what that's going to do is that's going to take it from one r equals 0 to another r equals 0. And that will translate, if I do it as y equals 2 sine of 3x, that will translate into y equals 0 to y equals 0, which is x-intercepts. What does that look like? Well, back to function mode here, and do y equals 2 sine of 3x. And we get something similar as we had before. So again, we're going from r equals 0 to r equals 0. And the zeros, that's y equals 0 to y equals 0. So I'm talking about from here to here. So I can figure out that part there, what those are right there. That tells me, okay, well, in this case, the period is 2 pi over 3. So one period, whoops, yeah, 2 pi over 3. Take 2 pi and divide it by whatever that is. So I've got 2 pi divided by 3, so one period would be there. So that's 2 pi over 3. So this would be, what would that be? 2 pi over 6? Halfway? Half of 2 pi over 3? Pi over 3. So I'm going from 0 to pi over 3. Make sense? See how I got that? So this, I figured out the period is 2 pi over 3, so that's this. So this would be half of the 2 pi over 3, wouldn't it? Huh? Yeah, I'd look. I would look. Because did it work that way last time? Yeah. Yeah, it just depends on, the other one was 1/4 of it, so yeah. You just have to go. I think it'll depend on cosine and sine, actually. This one's sine, so that may work for sine. All right. And the other thing is, in this case, I'm going from 0 to pi over 3. Right? So one loop is the integral from 0 to pi over 3 of the 1/2 r squared, which is sine 3 theta squared theta. Okay? Which is integral 0 to pi over 3 of 1/2 4 sine squared 3 theta. Square those both out. 4 cancels, gives me 2, so it's the integral of 2. Now what am I going to do with sine squared? Yeah, I'm going to use the sine double angle. Sine squared of theta would be 1/2 minus 1/2 cosine 2 theta. So 3 theta, well, that would be 3 theta instead of theta, so that's going to be 6 theta. So it's going to be 2 times 1/2 minus 1/2 cosine 6 theta d theta. 0 to pi over 3. Which, I guess that's why they're always putting 2's out here. I don't know if they always do that, but distribute the 2 in, so it's just the integral of 1 minus 1 cosine 6 theta d theta. So that would be theta. The integral of that's theta. Cosine 6 theta, well, that's just a little u substitution. U equals 6 theta. Du would be 6 d theta, so du over 6. So this is going to be minus the integral of cosine of u du over 6. So that would be theta minus the integral of cosine is sine, and it's 1/6 of that. Sine of u is 6 theta. 0 pi over 3. Is that okay? So plug it in, you got pi over 3 for theta. 1 over 6, so that would be sine of 6 times pi over 3. Plug in 0, 0 minus 1/6 sine of 0. That's all 0. So it just works out to be this. Let's see. So that's pi over 3 minus 1/6 sine of pi over 2, right? No, sine of 2 pi. Sorry. What's the sine of 2 pi? About the sine of 0, isn't it? It's just pi over 3. But what is that? That's one loop.